Oh, hello, hello. We are live. It's good. It's day two of the review, day three of the essay. So let's start without wasting any time. So the first question is sort an array of zeros, ones, and twos. Now, an array is given of us where the numbers are only 0, 1, and 2. So the brute force solution will be doing arrays dot sort using any sorting algorithm and using the most optimum one like the merge sort will get a time complexity of O of n log n. A better solution will be arrays that are containing 0, 1, 2. What we will do, we'll iterate on that array and then we will count the number of zeros, then count the number of ones, then count the number of twos. So then we'll again iterate on the array. Then, for example, if there are five zeros, then index 0 to 4 will put 0. Then there are four ones, then we'll from index 5 to 8 will put ones. And there are three twos. So from index 9 to 11 we will put twos. So this will take the time complexity of about 2n. The most optimal solution is using an algorithm called Dutch National Flags algorithm. uh, you should know about this algorithm and before if you want to be able to solve this question in an interview. So this algorithm uses three pointers: low, mid, and high. There are basic rules in it. The first rule being the extreme left or 0 to low minus 1 has all zeros. Then low to mid minus 1 has all ones. And then from high plus 1 to n minus 1 has all twos. So you can see from mid to high, uh, did I say high plus 1, right? So high plus 1 to n minus 1 is all twos. Then you'll understand from mid to high, there is the unsorted part which contains randomly 0, 1, and 2. So we'll solve it using mid pointer. We can also solve it using the high pointer, but we'll not do that. So for example, there's an array. Let me say, let's say 0, 1, 1, 0, 1, 2, 1, 2, 0, 0, 0. So the mid will point, so the entire array is unsorted. So the mid will point to the first element and the high will point to the last element. The low can also point to the first element because from 0 to low minus 1 is all zeros. And yes, this is true here. So A of mid can be what values? It can be 0, it can be 1, or it can be 2. So we will solve for different situations. So for A of mid equal to 0, we will put 0 in the left at low. We will put 0 in the left at lowest point. So as you know, 0 to low minus 1 is 0. Then low is 1. So when you will put low as 0 and we'll swap with mid as 1, it will still remain sorted, right? Because it will be 0, 0, 0, 0, then 1, 1, 1, 1. Because this low, it will be still be sorted, right? But what will be wrong? The rules will not be met. So according to the rules, we will move the low pointer and the mid pointer. Why we are moving the mid pointer? Because that part is sorted. Mid to high part is unsorted part. So we'll move the mid pointer also. When a of mid is 1, it is still sorted because it is still 0, 0, 0, 1, 1, 1, 1, 1. And according to the rules, we will just move mid because we move to the unsorted part. When a of mid is 2, then what we will do? Then we will swap with a of high. Now what will happen? This part will become sorted. So we'll move high. But do we move mid? We do not move mid because high could still have anything like 0, 1, and 2. Then we also have to process that 0, 1, and 2 again. So we'll not move mid. So this is the Dutch national flags algorithm. I'm actually a bit slippery. No, my tongue is slipping so much. We'll move on to the next. So moving on, we have the positive and negative rearrangement. So we have to rearrange elements by sign. There's an array given to us with equal number of positive elements and negative elements. Now we need to rearrange them so that the positive element order is maintained and element order is maintained, but there is alternative positive and negative elements. For example, if an array is given to us 3, comma 1, comma minus 2, comma minus 5, comma 2, comma minus 4, there is equal number of positive and negative elements. There are three of both, so the final array which we will return is 3, comma minus 2, comma 1, comma minus 5, comma 2, comma minus 4. So the brute force solution will be using an using two arrays, positive and negative, to store the positive and negative values respectively of n by 2 size, both each. Um, and then we'll notice that the in the final array the positive elements are at indices 0, 2 and 4, and negative elements are at 0, uh, 1 and 2. The what